Oscar Piastri's McLaren did not simply slow down. According to the claims surrounding this Hungarian Grand Prix retirement, it died without warning, turning a normal race into a mystery with no obvious answer. But there is one major problem. The attached source does not confirm that Piastri retired, does not identify a mechanical failure, and does not explain what happened inside the car. That means every dramatic theory, from electronics to hydraulics to the power unit, remains unproven. So the real story is not just why the McLaren stopped. It is why so many people are already certain about a cause that has not been confirmed. And by the end, the difference between evidence, assumption, and a genuine technical failure will become impossible to ignore. Subscribe to the channel. To understand what actually happened, we have to begin with the most uncomfortable fact in this entire story. The attached source does not confirm that Oscar Piastri retired from the Hungarian Grand Prix. It does not describe his McLaren stopping. It does not identify a warning on the steering wheel, a sudden loss of power, an electrical fault, a hydraulic problem, or a power unit failure. And that changes everything. Because the phrase, "died without warning," sounds like a conclusion. But without a confirmed team statement, race report, or technical explanation, it is only a claim. That distinction matters more in Formula One than almost anywhere else. A car can appear to stop suddenly for dozens of different reasons. Some are mechanical. Some are electrical. Some are caused by damage. Some are precautionary, where the team orders the driver to stop before a small problem becomes a destroyed engine or gearbox. From the outside, all of those situations can look almost identical. The car slows. The driver pulls away from the racing line. The steering wheel lights may change. The radio becomes tense. Then the race is over. But the visible moment rarely tells the full story. Think of a phone that suddenly turns off. The screen goes black, but that does not tell you whether the battery failed, the software crashed, the device overheated, or someone simply held down the power button. The final result looks the same. The cause can be completely different. That is the first trap in this story. People see a car stop, then immediately search for one dramatic explanation. The power unit died. The electronics failed. The upgrade caused it. McLaren ignored a warning. But none of those explanations can be treated as fact unless the team, the driver, or reliable technical reporting confirms them. And the attached material does not provide that confirmation. So the real investigation begins somewhere else. Not with the exact component. With the sequence. What happened before the supposed retirement? Did Piastri report a loss of power? Did the team tell him to change settings? Did the car begin slowing gradually, or did performance disappear instantly? Was there contact earlier in the race? Did the team detect dangerous temperatures or pressure readings? Those details would separate a sudden failure from a controlled shutdown. And without them, every theory is missing its most important piece. But here is where it gets interesting. A Formula One car almost never fails in complete silence inside the garage. The driver may feel no warning. The audience may hear no warning. But the engineers are watching streams of data from the car every second. Temperatures, pressures, electrical signals, energy recovery, gearbox behavior, fuel flow, brake systems. The driver may believe everything is normal, while the pit wall has already seen a number moving in the wrong direction. That means, died without warning, can describe the driver's experience without describing the team's experience. Those are two very different things. Imagine driving your road car while a mechanic sits beside you with a laptop connected to every system. You may hear nothing unusual. The engine may still feel smooth. But the mechanic can see that one temperature is climbing toward a dangerous level. To you, the problem appears suddenly. To the mechanic, it has been developing for several minutes. That is why radio messages matter so much. A simple instruction to avoid certain curbs can suggest the team is protecting the floor or suspension. A request to change a switch setting can point toward an electrical or energy issue. An order to stop the car immediately can mean the team believes continuing would cause serious damage. But without those messages in the source, we cannot responsibly attach one meaning to the incident. And that creates a second problem. The title promises that we know what actually happened. Right now, based only on the attached material, we do not. We know what is being claimed. We do not have the evidence needed to prove it. That may feel frustrating, but it reveals something important about modern Formula One coverage. A dramatic explanation often appears before the official explanation. Fans freeze on board footage. They study dashboard lights. They listen to radio clips. They compare the sound of the engine. Sometimes those clues point in the right direction. Sometimes they create a story that sounds technical, but is completely wrong. A light on the steering wheel may be normal. A strange engine sound may come from the driver lifting the throttle. A sudden loss of speed may be an instruction from the team, not a component breaking by itself. And once one theory spreads, every new detail is forced to fit it. That is how uncertainty becomes certainty without evidence. But Piastri's situation, if confirmed by a proper race source, would raise a larger question for McLaren. Was this an isolated problem? Or was it connected to a broader reliability concern? One retirement can be bad luck. Repeated failures in the same area suggest a pattern. But a pattern requires more than one dramatic headline. It requires dates, components, team explanations, and comparable incidents. None of that appears in the attached source. So for now, the only honest conclusion is that the cause remains unspecified. And yet, even that absence tells us something. If McLaren had immediately identified a simple, routine issue, the explanation would likely be straightforward. A sensor failed. A component overheated. Damage ended the race. But when details remain unclear, speculation grows because the gap feels important. That gap may be temporary. Teams often need time to inspect the car, remove components, examine data, and determine whether the first visible symptom was the real failure or only the final consequence. A car may stop because the electrical system shut down. But the electrical shutdown may have been triggered by overheating. The overheating may have been caused by damage. And the damage may have come from something that happened many laps earlier. The first answer is not always the deepest answer. That is why the final diagnosis can look completely different from the original assumption. The part everyone blamed may be innocent. The real problem may be hidden farther upstream. Like water leaking through a ceiling. The wet patch is obvious. But the broken pipe may be several rooms away. And this is the point where the Piastri mystery becomes much bigger than one car stopping. Because the most important question is not what the audience saw at the end. It is what McLaren's data showed before that moment. That information would reveal whether the failure was truly sudden, whether the team had time to react, and whether the race could have been saved. Until that evidence appears, every confident explanation is standing on missing ground. And the next clue would have to come from the one place speculation cannot replace. Piastri's radio, McLaren's official diagnosis, or the technical inspection after the race. The most revealing part of a Formula One failure is often not the moment the car stops. It is the decision that comes immediately before it. A driver may feel a loss of power and assume the engine has failed. The pit wall may see a pressure drop and decide that continuing is too dangerous. The audience hears one urgent radio message. Then the car is parked. To everyone watching, it looks sudden. Inside the team, it may have been a controlled decision made in seconds. That difference matters. Because when a car is retired to protect it, the final failure may never actually happen. The team stops the car before the damaged part destroys something more expensive, more complicated, or more difficult to replace. Imagine hearing a strange sound from your kitchen. You switch off the electricity before smoke appears. Later, someone asks why the entire system failed. But it did not fully fail. You stopped it because the warning was serious enough. Formula One teams do this constantly. They are not only trying to finish the race. They are protecting the power unit, the gearbox, the battery systems, and the car itself. One small problem can spread. A loss of oil pressure can damage moving parts. A cooling issue can raise temperatures quickly. An electrical fault can affect several systems at once. And a damaged component can send debris into areas that were working perfectly seconds earlier. That is why the word failure can be misleading. The car may stop because one system has already broken. Or it may stop because the team is trying to prevent the real disaster from happening. But the attached source does not tell us which of those situations applied to Piastri. It does not provide the radio message. It does not provide the team's diagnosis. It does not provide the technical sequence. So the most important distinction remains open. Did the McLaren die? Or did McLaren decide it could no longer be driven safely? Those are not the same story. And this is where the phrase "without warning" becomes even more complicated. A modern Formula One car can produce thousands of signals during a race. The driver cannot monitor all of them. That is not his job. He feels the car through the steering, the brakes, the throttle, the sound, and the movement beneath him. The engineers monitor everything else. A temperature can rise while the car still feels normal. A pressure can drop before the driver notices any change. A sensor can detect a problem before the mechanical part begins making noise. The warning may exist. It may simply exist somewhere the driver cannot see. That would explain how a retirement could feel instant inside the cockpit, while the garage had already begun reacting. But there is another possibility. The warning itself may have been false. Sensors do not only report failures. They can fail too. And when a sensor sends an impossible reading, the team has to decide whether the car is truly in danger, or whether the information is wrong. That decision must be made at racing speed. There is no time for a long discussion. No time to stop, inspect the car, and continue. The engineers must choose. Trust the reading. Ignore it. Change a setting. Reduce power. Or retire the car. One cautious decision can end a race that might have continued. One reckless decision can destroy a component that might have been saved. That is the pressure hidden behind a simple radio command. And for Piastri, the timing of the problem would have made the situation even more painful. A driver can accept a slow car. He can fight with poor balance. He can adjust his braking. He can protect the tires. But a sudden technical problem removes control completely. The driver becomes a passenger. The race disappears, not because of a mistake, not because of a bad overtake, and not because another car was faster. It disappears because something inside the machine has made the decision for him. That is one of the most brutal feelings in Formula One. Especially when the car had the potential to score heavily. Especially when the teammate side of the garage appears to be functioning normally. That contrast creates immediate suspicion. Why did one McLaren survive while the other stopped? Were the cars using different parts? Were they running different setups? Did one car suffer damage? Did one component reach the end of its life? Or was the problem completely unrelated to the package that had attracted attention earlier in the weekend? The source does not answer those questions. And without those answers, the comparison between Norris and Piastri can become unfair. Two cars from the same team are never perfectly identical in every meaningful sense. They may use the same design, but individual components can have different mileage. Setups can change. Cooling choices can differ. The drivers can place different loads on the car. Even the way they attack curbs can affect stress through the floor, suspension, and bodywork. Think of two identical pairs of shoes. One is brand new. The other has been used for several long runs. They look the same. They are not carrying the same history. Formula One components also carry history. Every lap adds heat. Every curb adds load. Every vibration adds stress. A part can remain healthy for thousands of moments, then reach its limit with almost no visible warning. That does not mean the design is fundamentally flawed. It may mean one component failed. But one isolated failure and one design weakness are very different problems. An isolated failure can be replaced. A design weakness can affect future races. That is why McLaren's final diagnosis would matter so much. If the issue came from one damaged or defective component, the team could inspect similar parts and move on. If the issue came from heat, installation, vibration, or a weakness in the wider system, the consequences could be larger. The team might need to change how the car is prepared. It might need to alter cooling. It might need to reduce stress in certain conditions. And any protective change can cost performance. That is the trade Formula One teams fear. Reliability versus speed. Push too little, and rivals disappear ahead. Push too far, and the car may not reach the finish. The fastest possible car is useless if it cannot complete the race. But the safest possible car may never be fast enough to win. Every team lives between those two dangers. And when a car stops suddenly, the balance between them is questioned immediately. Did McLaren chase performance too aggressively? Was the car operating too close to a limit? Or did the team suffer the kind of unpredictable failure that can happen even when every calculation appears correct? There is not enough evidence in the attached source to choose between those explanations. But one clue would separate them quickly: whether McLaren changed anything on the other car after the incident. If a team sees a problem that could affect both cars, it may change settings, reduce power, alter cooling instructions, or tell the remaining driver to avoid certain areas of the track. Those actions can reveal concern before any public statement is made. But again, the source does not provide that information. And that absence keeps the central mystery alive. Because the real cause cannot be identified from the final image of a stopped McLaren. It has to be traced backward. From the retirement. To the warning. From the warning. To the system that produced it. From that system. To the component, damage, temperature, or signal that started the chain. Only then can anyone say what actually happened. And the next part of the story is where many explanations fall apart. Because the first component blamed after a retirement is often not the component that caused it.